In this discussion, we're going to consider whether competitive markets are efficient. We've studied the model of competitive markets. We've called it the competitive equilibrium model, with buyers and sellers and coming together in a market. To examine whether that market is efficient, we need to think about how the model works and how it describes reality. We first need a definition of efficiency, though. What do economists mean by efficient? And we've got to be quite specific because there's different ways to think about efficiency and whether markets are working well. The measure of efficiency that we use most often is called Pareto efficiency, and it has a specific meaning, which you can see on the screen: a situation where it is impossible to make one person better off without hurting another. So what you'd like to do to improve efficiency is make people better off without hurting someone else, or to make one person better off without hurting someone else. And if you're in a situation where you can't do that, you can't improve at least one person without hurting someone else, then it's an efficient situation. So let's best think about this in terms of an example. So let me get off camera and see if Thomas and Tilke would help me understand this with you. So as you can see, Thomas and Tilke each have three objects. Tilke has two hats and a book, and Thomas has two pairs of sunglasses and a book. Is this Pareto efficient? No, because it's possible to make one of them better off, in fact, both of them better off, without hurting the other. How do we do that? Exactly. Because having two pairs of sunglasses with no hat doesn't help you out much on a sunny day. Having two hats and no sunglasses doesn't deal with that glare, but if you got a hat and the sunglasses, you're in a better situation. So this has made them better off. This is now a situation where they're better off than they were before. We made them better off without hurting each other. Is this Pareto efficient at this point, though? Is there another change that we could make regarding these three objects to make one of them better off without hurting another? Well, maybe Thomas could have two books. Okay, Thomas is better off, he's got his two books, but note that poor Tilke is harmed. She has no books. And so the situation where they were each holding the book, back again, was Pareto efficient because it was not possible to make one of them better off without hurting another. And that's the best illustration of Pareto efficiency that comes from regular people with sunglasses, hats, and books. Thank you, Thomas and Tilke. We can think about several ways to be sure that the markets are efficient, or that the distribution or production is efficient. And these are conditions that are necessary to hold if you're going to have efficiency, and particular Pareto efficiency. Let's go through each one. One is that the marginal benefit of producing a good is equal to its marginal cost. If the marginal benefit was greater than the marginal cost, then you should be producing more of that good. If the marginal benefit is less than the marginal cost, then you should be producing less of that good. It is not worth the cost. It's only when that they're equal, marginal benefit is equal to marginal cost, that it should be efficient. The second thing is you would like the marginal cost of each good to be the same for all producers. If the marginal cost was really low for producer A and high for producer B, then it would make sense for producer A to produce more because the costs were low than for producer B. It's only when the producer A and producer B's costs are equal that you can't do better in terms of reducing costs. And then finally, marginal benefit for each good should be the same for all consumers. Because if it wasn't, there would be some gains from trade. If the marginal benefit of a rose was greater to me than the marginal benefit to you, then it would be a good idea for us to trade and for me to get the better marginal benefit compared to you. It would be worth you to sell me that rose and make the marginal benefits the same. So it's only when they're the same that we're in this efficiency thing. Whenever these conditions don't hold, it's possible to increase production for one person, increase consumption for another person, and everybody will be better off. It's only when these are all holding that you can't make people better off without hurting someone else. That's Pareto efficiency. This is a statement about people, production, costs it actually doesn't even mention the markets. There's no mention of a market in this definition. It's a description of what society should look like for efficiency. Marginal benefit is a description of people's preferences, you recall. Marginal cost is a description of how much it costs to produce things based on the production function. So neither marginal benefit or marginal cost necessarily relate to a market system. They relate to people and to productions. Now the question is, does the market system give you these conditions? And if it does, we can conclude that the market system is efficient. As an example, you might want to think about the following data. These are data on magnetic research imaging scanners, basically scanners that enable doctors to diagnose various kinds of things going inside your body. It turns out there's quite a difference in the number of scanners per population, per million if you like, in the US versus the UK and Canada. In the United States, there's much higher number of scanners per person than in the UK or Canada. Now one might ask the question, is the US producing too many scanners? Or is the UK or is Canada producing too few scanners? So the question really has to do with the marginal benefit of more scanners and the marginal cost of producing those scanners. You might say, oh, the US is producing too much, or someone else may say that the UK is producing too little. Who knows exactly, but this is an illustration that you need to think about the marginal benefit and marginal cost in order to reach a conclusion about this very important kind of public policy issue. So given that, let's now think about what the market would give you in terms of efficiency. Question is, are the conditions for a competitive market satisfied, and do they give you the conditions for Pareto efficiency? Number one, marginal cost is marginal benefit. Why is that the case? Because you recall in a market, there's an equilibrium at the intersection of the demand curve, which is the marginal benefit, and the supply curve, which is marginal cost. So that intersection, the quantity demanded and the quantity supplied are equal, so marginal benefit is equal to marginal cost. So the first condition of Pareto efficiency is actually satisfied by the market. What about the second? Well, we know from the derivation of the demand curve and utility maximization for consumers that people will adjust their consumption so that the marginal benefit is equal to the price. And that's true for each consumer. Each consumer is out there deciding how much to consume by looking at the price, whether it's the price of pumpkins or the price of gasoline or the price of bicycles. Since each consumer is facing the same price in this competitive model, that means the marginal benefit for every consumer is the same. Marginal benefit is equal to the price is the same, so the marginal benefit is the same. So just to repeat, the marginal benefit equals the price for each consumer because each consumer sets the marginal benefit to the price, and because there is a single equilibrium price, we call it P, in the market. And then finally, in a competitive market, the marginal cost is equal to the price for each firm. That was the implication of the firms maximizing their profits. And the reason is that each firm sets marginal cost equal to price, and because there's a single equilibrium price in the market, all the marginal costs for the firms must be equal. So amazingly, the conditions for Pareto efficiency, which we wrote down not even thinking about a market, are satisfied through the competitive market. All those conditions hold. So the answer to the question, is a competitive market efficient, is yes. All three conditions are satisfied. You can think more about this by looking at the graphs and the supply and demand curve. So here's an example of any market. I've drawn in a market supply curve, upward sloping, a market demand curve, downward sloping, with quantity on the horizontal axis and price on the vertical axis. We know that the prediction of this model is that the price and quantity will be at the intersection of the curves. And according to our definition of efficiency, that is an efficient point. Marginal cost is equal marginal benefit on those curves. You could be producing away from that point. It could be producing too much, as illustrated in the picture. In that case, at the too much, the marginal cost is greater than the marginal benefit. So it may be those MRIs, the marginal cost of producing them is much greater than the benefit when you have so many. On the other side, there's too little if the production is below this efficient point. And that too little, you can see now the marginal benefit is greater than the marginal cost. So it would make sense to produce more because people would benefit from that more than the cost would be. So who knows, maybe that describes the situation with respect to the UK or Canada, where the marginal benefits would be greater if they produced more. In any case, this illustrates this notion of efficiency and being inefficient, either too much or too little. Now, once you think about and look at inefficiencies in a market as being away from the market equilibrium, you can now begin to measure how well the market works, got a quantitative measure of how good it is compared to other things. And to get this measure, we want to use this concept of producer and consumer surplus, which we've defined already. And note that in an equilibrium of a competitive market, the sum of producer surplus and consumer surplus is as large as possible. We're going to derive that. We're going to show that's the case. Another way to say it, as we'll see, is the marginal benefit less the marginal cost of all the items produced is as large as possible. And finally, the third way to put this, as we'll say, is we're going to say in a market the deadweight loss is eliminated if that market is competitive. Now let's do some pictures to show this. So I've drawn in these pictures 3 supply and demand diagrams to illustrate 3 different points. In the one in the middle, I'm looking at the market price and the amount produced. That's efficient because they're at the equilibrium. And I've shaded in the total producer surplus and consumer surplus. Remember, the producer surplus is the area above the supply curve, below the price, and the consumer surplus is the area below the demand curve, above the price. So that's the area of total producer plus consumer surplus that comes out of this market equilibrium. But suppose, on the other hand, you were producing less than that, too little, say, then you're going to lose some producer surplus and consumer surplus. The amount of loss is the sum of the areas of A plus B. You've lost A in terms of consumer surplus and B in terms of producer surplus. Those are lost because you're producing way over where it says too little. That loss we call deadweight loss. It represents the fact that too little is being produced. It's a loss because the marginal benefit for all of the production in that gray area is greater than the marginal cost, deadweight loss. And you can also think about it in the case of too much being produced. In this case, there's the too much. And now what you've actually done is created negative producer surplus and consumer surplus, which is the area C plus D. Negative producer surplus in the sense that the marginal cost on the supply curve is greater than the price, and negative consumer surplus in the sense that the marginal benefit as represented by the demand curve is lower than the price. So this deadweight loss, then, because it's an area there, represents a measure, a quantity measure of how much you're losing by being away from the market equilibrium. You can think about the deadweight loss as coming from many different things. As we'll see as we proceed with the principles of economics, it can come from a tax. For example, a tax on firms that the firm has to pay a tax to the government raises the marginal cost for each firm. In that case, as we know, if marginal costs rise, the supply curve shifts up by the amount of the increased marginal cost, in this case by the amount of the increase in the tax. When we know from the basic supply and demand model, when the supply curve shifts up, the quantity produced falls. We'll see that, and you'll see that the price rises. It's interesting, which you'll see that the price rises by less than the tax. But most important for this lesson, deadweight loss is created. So let's look at the diagram, supply and demand diagram, and see how that works. And let's do it in the case of something that's discussed a lot from time to time a device on particular taxes. This is what's called the medical device tax, where firms pay a certain amount of tax when they produce a medical device. So for example, if an inexpensive wheelchair costs $100, the tax is $2.30. So let's use this example to illustrate the impact of the tax and the deadweight loss. Here's our diagram, which we've seen many times before. The red line represents the demand curve. The lower blue line, the lighter blue line, represents the supply curve before the tax is put into place. Now we consider the tax, and the tax is represented by the arrow that moves up in the picture, the marginal cost curve, the supply curve, rises by that amount. And so we now have a new equilibrium, and the new equilibrium is at the point here where there's a higher price and a smaller quantity produced. So our prediction, therefore, if you move from the without the tax to the tax, move up along that curve, price is higher, and the quantity produced is lower. So if you look at the bottom, you can see the quantity produced goes down, and if you look over here, you can see that the price increases. Now, there is a deadweight loss, as we've defined it, because there's less production than without the tax. The production is over here with the tax compared to over here without the tax. So production goes down, and that creates the deadweight loss in the picture, that area where the marginal benefit of, in this case, the wheelchairs is greater than the marginal costs. And the marginal cost is increased simply because of the tax. And then finally, in the diagram, in the lighter shaded area, you can see the amount of tax that's paid to the government. The tax is the amount of the height of that rectangle. That's the amount by which the curve shifted up. And the total amount sold is the length of the rectangle. So the tax times the number of wheelchairs or whatever is sold represents the total revenue to the government, and it's basically the area in the lightly shaded area part there. So that represents not only the deadweight loss, but also the revenue to the government. The revenue going to the government itself is, of course, not a deadweight loss. That's a transfer. But the really loss of production, which creates the deadweight loss, is because the production has moved down. Finally, let's consider where we are so far in this supply and demand model and efficiency. We've derived the demand curve, and we've considered consumer surplus. We've now derived a supply curve, and we've derived producer surplus. In each case, we considered the mantra of economics that people make purposeful choices with limited resources. In the demand curve, maximizing utility subject to a budget constraint. In the supply curve, maximizing profits subject to a production function. From these, we considered the competitive equilibrium model, where firms and buyers and sellers and consumers are in the market, buying and selling, taking the prices given, and we get a prediction of what comes out of that. That prediction is amazingly efficient. The amount produced is efficient. The amount that each person gets is efficient, and that's our Pareto efficient concept. And that's why economists frequently say that competitive markets are efficient. And when we do this, when we derive all this, we're actually deriving a very famous theorem in economics, sometimes called the invisible hand theorem, originally due to Adam Smith. The invisible hand theorem said that people maximizing their profits, people trying to do the best they can for themselves, if there's competition, will generate a good outcome. It's the invisible hand because there's no one hand in there trying to make this all happen. It occurs because of the, if you like, the apparently uncoordinated actions of firms and consumers in the market. And it derives this, it implies this efficient outcome. Now, of course, there's a lot of assumptions that have gone into this, as we've been careful in deriving in the last few lessons. And as we go forward in the course, we're going to consider deviations from these assumptions, where markets are not competitive for one reason or another. And then we'll see the ways in which the market in some sense fails and the role for government in those cases. Thank you.